All right, 6.3 is about collecting in automated manufacturing systems. Now, this is how the automated manufacturing systems or factories that are automated are collecting the data that they need to make a decision about. So we're learning about the sensors that are used, but also the processes that happen. So what we start with is, of course, CAD/CAM is the most important part of this aspect. When we see that this is a image of CAD/CAM where a draftsman or an engineer or someone who works in the field of automated manufacturing industry is designing a product, and over here is the manufacturer or the machine that actually manufactures that product. So what do we need in regards to this? Well, of course, if we look at in our textbook figure 6.7 on page 198, which looks like this, you can see that there is the person who is working, who is generating all of these types of things, or not all of them, but this person can work on these or one of them, and the information is gathered into a database, and then that's the CAD side of it, and then going across to the CAM side of it. These are the things that can happen in regards to each of these. So for geometrical modeling, we might be actually doing some sort of construction or something like that, or even say a robot is doing that. Now, it's interesting to say that in regards to the syllabus, I might actually just pause this and get the syllabus. So, sorry, just pause that so that I could get the syllabus loaded on my screen. So, when we're talking about collecting, the syllabus talks about obviously the dot points where we're learning about these things, but then it comes down to this part here, which it says that you need to sort of understand the processes. Over here we're talking about, so we're talking about not only learning about the different things, but also how, once we've learned about the sensors, what do we do with them? And it talks about the integration of the sensors using robotics arms and conveyor belts. Then it says you have to know how to use a range of available sensors to collect data that could be used in an automated manufacturing system. So the textbook talks about how that's done, and I'm going to explain that today in this video. So if I go back to my Prezi, you can see that I've asked you to look at that figure. But then we move on to seeing, obviously, that an automated manufacturing system, which we just looked at before, requires high performance computers, and I just had a picture of just a CAD workstation, compared to a drafting workstation, which would have high amount of processing, especially in terms of if you were to develop something that was, say, a 3D model, and then you wanted to render it to see what it actually looked like. It would require a lot of processing and also storage as well. We also need a plotter. So a plotter looks like this. This is what's known as a flat bed plotter. Where I'm moving my mouse, the arm, it moves backwards and forwards across this way, but the arm also has a pen on it that can move sideways as well. So it's actually printing out the information here for, say, a architectural design or something like that. Interesting to note, this is an old picture because we have a 5 1/4 inch floppy disk here, so you certainly would not know what that was or what it looked like, but you may you would know what it looks like, but you probably definitely never used one before, and they were sort of before my time as well. The next one up was the 3 1/4 floppy disk, and that is obsolete by obviously memory cards now that we have. So that's just one aspect of automated manufacturing. Now, of course, CAD software provides these things: image manipulation, transformations, library and file management. So that's what we're talking about in regards to the manufacture of products using CAD software. Then, of course, we have what's known as CIM, which is computer integrated manufacturing. I have placed on our OneNote site some videos, and I've got obviously a video that explains what a CIM is. So pause this video, jump on and watch this video. I do also have in the Prezi a little bit of a muck around video about CIM, which gives you an idea of what that is. And you can also use the textbook to write some notes about what CIM is, and then we're going to move on to sensors. So pause this video and then watch the videos about what a CIM is. Okay, so the next part of computer-aided manufacturing is also sensors, and we have to know, if you look at the syllabus, if we go back up here, it says you have to know the physical operation, the scientific principles underlying sensors used to collect data, including temperature, pressure, motion, flow, and light. So you have to learn through visual representation and also note-taking all the different types of sensors. So in your textbook, there is information about each of the sensors. In your OneNote, I have listed each of the sensors and also barcode readers, and the videos listed here explain how each of them are. So you can certainly pause this video and go ahead and watch them and take some notes. But I'm just going to basically explain them in this video now. So we have sensors, and the first one is also known as transducers, and what they do is they need to be highly accurate, high resolution, high repeatability, high range, and dynamic response. So not all of them do all of this, but they do need to be able to do this so that they can work in the manufacturing industry. So the first one is temperature sensors, and there's two types. There is thermocouple and also thermistor, and I have a couple of videos on how each of them work. And for example, the application of each of these types of sensors is, you can use them in, for example, dryers so that they measure the temperature, but also you can use them in ovens. So please watch those videos on each of the different types and take a bit of notes on that. The next one is pressure sensors, and they measure the exertion of force. And I've got a couple of examples. They also measure them using a diaphragm. So in this diagram here, you can see this little bubble here. Inside here is water, and it measures the PSI, pounds per square inch. And so you can see here that, or kilograms per centimetres squared. Right, so this is a gauge that actually measures that. Pressure sensors are used for even just a simple thing like measuring the amount of air that is in a tyre. So we use a pressure gauge for that. And some of pumps actually have the pressure gauge put in them so that you can fill a tyre with the amount of air that is required. Another one, for example, is this guy here. I'll click that. He's got in his hand a barometric pressure gauge, which measures the barometric pressure is the air pressure on Earth. And with that, we can make decisions on what the weather is doing. I have one in my house and I look at it all the time. Today, for example, I know that the barometric pressure will be very low. So we've got a low, and of course, it relates to outside at the moment, it's raining, and it's forecast to get the weather's forecast to get really ordinary. Now, in the summer months, the barometric pressure is very high, which means that the pressure on the Earth is very high, meaning that it's quite warm. And so we can certainly look at different areas of what's happening in the world and make decisions about weather based on barometric pressure. So that's one way of an application of using a pressure gauge. But in the automated manufacturing industry, it's usually related to if you have to, say, heat water to form steam, then of course the steam is also pressured, and we have to measure that pressure in case it gets too much and maybe something might explode or something. So it's a safety issue as well. Then we have, of course, motion sensors, and I've got a video here. I've done it again. I'm just going to skip this video. No, I'm not. Motion sensors allow us to actually check whether or not something's moving, or even we have alarm systems that measure movement and make a decision about that. The next video on this Prezi is from Mythbusters, proving that you can beat a motion sensor or an alarm sensor. So you can go ahead and watch that if you like, and then I'll come back and talk to you about it. Also on that, we do have how motion sensing works and its applications in the automated manufacturing. And then the next one is flow sensors, which measure fluid, of course. And you can see here that the fluid in this diagram, the fluid is moving in this direction, causing this wheel to turn. Now, there would be a gauge on the other side of this that would show that this is moving, and it would be a dial that would read the motion, or it would then force, say, pressure up into here and then have a pressure gauge up there. There is a video on this. It is right there. I'm not going to show the videos in these ones, of course, and I also have uploaded to our OneNote what a flow sensor is and how it works. So you can go ahead and watch those videos now after you pause this one. The next one is light sensors, and I've got a picture here of a Lego Mindstorms NXT light sensor. It can measure black and white light, and it can also measure color as well. And these ones are used in Lego to actually follow a line, and I'm not sure whether you guys have done this before, but I've done this lots and lots and lots of times, where I've taught students how to actually program a robot to follow a line so that the robot moves. Lots and lots of people do know how to do this. Light sensors are used a number of ways. For example, just simply a product moving down a conveyor belt will produce some form of light, and a light sensor can pick up. But most of the time it's done through motion sensing as well. Also, I do have a video here about how these light sensors work, and in our OneNote there is also a how the light sensor works, which is the same video that is on the Prezi. So go ahead and watch that one as well, and take some notes through your textbook as well. Then we have barcode readers. Now, barcode readers look like this, and of course the barcode reader is shining a laser and using a light sensor to actually recognize the black. It's not recognizing the white, and it's recognizing the thickness of the black as well. I do have a video here that explains how QR codes and barcodes work from As Fast as Possible, which is a YouTube channel, and it is very helpful to explain. For example, he says that barcodes you can only read a certain amount of numbers, whereas QR codes are pretty much unlimited, and that's why we moved to QR codes. Barcodes are used in automated manufacturing to inventory track, so that's important, of course. And then, of course, we look at what do we do once we know all the different types of sensors. Well, we do obviously inventory management, and there's a little video here on inventory management, but I'm going to move on. And then you need to understand that all this stuff of working with sensors means that we can convert analog signal into digital signal. So there is a little bit about analog to digital conversion in your textbook. A little bit of a table about that as well. So we're looking at temperature and producing volts. Of course, we can get temperature to convert to volts. We can even get light or UV to convert to volts as well. And that's why we have solar panels on our roof, for example, which I have mentioned before in the past. And then we have another, and table 6.2, we've done that. Then we have another thing called damping. Now, damping is where, in automated manufacturing systems, I want you to picture a conveyor. So I will Google conveyor. I spelled it wrong. I meant conveyor. Belt conveyors images. Alright, so let's have a look at this image here, and I'll blow it up so that it's big, and I'll explain to you what damping is. Okay, so here we have a conveyor where it looks like these are parcels, and let's say they're from a mail sorting place. They're coming down one conveyor, and then they're going on to another, and then they're going along here. Now let's say in the process of this, that when it gets to here, a sensor detects that this parcel is here, and a stamp has to be placed on this. A stamp has to be placed on this. So when the parcel comes down here and travels to this point, we need to make sure that the stamp hits this parcel at the exact correct moment. And what that is defined as, when it does it correctly, it's done as critical damping. Now, critical damping, let's have a look at this, right? So critical damping is the preferred rate of change in the output of a system, right? And there's a diagram here that explains critical damping. So what we have is everything here is perfectly timed in critical damping. Now, if it comes down here and the sensor detects that it's there, and then this parcel moves on, and the stamp comes down and hits the table instead of hitting this parcel, right? The parcels happen too quick. Now that's defined. Let's have a look at this. Right, under damping is if the change is too fast. Right, so that means that the parcel moved too fast, and of course under damping occurs. Now the opposite of under damping, of course, is over damping, which is the change is too slow. So let's get our diagram back up here again. Let's say that this happens, all right? The sensor detects that this parcel is here, but the parcel hasn't arrived yet, and then the stamp occurs. So that's the opposite of under damping, which is known as over damping. Now, what I've seen in the HSC questioning about automated manufacturing systems, when it comes to asking a question about damping, most of the time it's about a 1 or 2 mark question where it says, define one of these. There hasn't been really an analysis or describe or outline. It's mainly just identify the term. So we know the verb identify just basically means state what it is. So if you can learn these 3 definitions for damping, then it's quite straightforward that rote learn these 3 definitions, and maybe watch this video a couple of times so that you understand it, and then you should be fine to be able to answer any questions in any form about damping. I'm obviously going to put some homework questions up in our OneNote, and one of the questions will be to define these. So that's the conclusion of 6.3, collecting data in an automated manufacturing system.